ever since 2006 until last night, no failure. So for almost, we're talking about now 18 years, right? 18 years, no failure.
Give us an example of what is a great AI application that has sustainable performance that can be mapped and scaled.
Well, for example, we work with Toyota, right? Georgetown, Kentucky plant.
Yep.
In where Camry model was built, right? So that's Georgetown, Kentucky.
Yep.
2006, we had the opportunity to work with the president of Toyota Georgetown, Kentucky, was Mr. Niimi-san. Mr. Niimi was the president. So he said we have some kind of random failure of production, including compressors. There's any way we can remove those failure out, right?
Because it's random.
Exactly. I don't want to 1 year happen January, another year happen February. They randomly happen different time.
Yeah, it's like a bug you can't reproduce only in a car.
Yeah, so can we do that? So we took that as a very great challenge, and we implement a principal component analysis and the support vector machine. And ever since 2006 until last night, no failure. So for almost, we're talking about now 18 years, right? 18 years, no failure. Well, there's no surprise downtime, but there's a maintenance downtime. But I physically schedule you to down for maintenance. That's fine.
But how did the support vector machine catch this in the beginning when it's just ramping up and collecting data?
Well, it's a classification tool, right? How do you classify the surge? When a machine is a surge, compressor surge happen, the machine just shut down in 2 seconds. But how do you prevent a surge? By using the flow sensor, by using the pressure, you can predict and classify potential risk of a surge. Then
so you created a feedback loop, studied the pattern and the feature, classified, and then created action drivers on that.
Yeah, so what you do is if you detect the likelihood of surge, you can open the inlet guide valve early, relieve the pressure, so the machine never have a sudden failure, right?
That's a great story. So now let's come to this time in our journey. Can you imagine implementing what you did in 2006 with what you have today, cloud, industrial IoT, Gen AI? What? Now go back to that point and to today. Like, how long did it take you? And
well, that project took us 6 months, right? Then we had the mistakes first. We located wrong problems, but later on we have a number of other projects. Sometimes 3 months, sometimes 1 month. So eventually, my question will be, if the problem need to be similar problems, I don't need 6 months. I can finish it in 3 weeks, 3 days. How about 3 hours, right? 1 day, right?
Yeah, so that's my question. If the same problem from 2006 to today, so it's like proportion of almost like 20 years, right?
Yeah.
Almost. How long would it take today?
Days.
We just got days. You're saying we're in days. So we moved from months.
We'll be able to finish in 2 days. Through 2 to 3 days, yes. Which will already demonstrate some of the problems we did this last year. Student did it in 2.5 days for the special project of a space shuttle that from Japan NASA. They can detect the likelihood of valve failure. That was a data challenge project we did. So students spent 2.5 days and 100% prediction, 100% correct, yeah.